Your Excellency, ladies and gentlemen, my name is Mohammed Al-Abri. I'm going to be the moderator for the session today at the UAE Pavilion at COP26 Glasgow to explore more about the innovation solution to attain water security and the UAE leading efforts towards tackling water scarcity. Here with us, Mr. Sufyan Farrah, cloud seeding specialist at the National Center of Meteorology, will be presenting the cloud seeding operation in the UAE. And Ms. Ali Al-Mazroui, Director of the UAE Research Program for Rain Enhancement Science, who will be representing the Rain Enhancement Program. We would have a 10 minutes discussion after the presentation. Mr. Sufyan, please go ahead.
Thank you very much, Dr. Al-Abri, for having me here. Thank you also for this opportunity to be in the COP26 to address you, ladies and gentlemen, about the cloud seeding operations in the UAE. The country is not suffering from the shortage of fresh water, but it's crucially suffering from the deficiency of natural water resources such as rain. Together we work with the different highly sophisticated centers such as ANCAR, the National Center of Atmospheric Research, Witwatersrand University from South Africa, and NASA, the space agency from USA. Together we work as one group, and we started to investigate the cloud types and the chemical and physical properties available in the country. So we did many experiments holding take measurements for airborne measurements for 2DC, 2dB, and BCASP to understand what are the pollutants available in the atmosphere, because some of these aerosols has inhibit for the cloud formation or augmentation, but others are good for augmentation of the cloud. So we started this to understand the different resources or sources of dust pollutants that are confluencing here in the country. Some of them are coming from the north of Kuwait, south of Iraq, and traveling about 3,000 toward the country, involving the atmosphere with different aerosols. Most of these aerosols are metallic aerosols or metallic cloud condensation nuclei that is favorable for the ice nucleation process. And some others are coming from the Sistine Basin, from the eastern parts of Sistine Basin, and some are coming from the empty quarter of the UAE. The empty quarter, this source is good for because it's coated, these salts are, sand particles are coated with the sulfate, it has high affinity for collecting the moisture, but unfortunately, the size distribution of these dust are ultra-giant particles. The other sources are coming from the subcontinents of China, and these are mostly organic materials. So all of these aerosols are confluencing in the atmosphere of the UAE and has a different effect for the cloud droplet and cloud augmentation. Because of cloud seeding operations, we of course built up a good infrastructure. We distributed more than 100 automatic weather stations over scattered parts of the UAE, in addition to about 30 rain gauges on scarce or dispersed areas, to especially to the southwestern region. The national radar network, what is it? The national radar network, we have 5 stationary radar networks distributed over scattered parts of the UAE to cover all the atmosphere of the country. Studying the climatological features of the UAE atmosphere, in winter time, we have about 4 systems approaching the country from the west and the clouds start to develop over the western islands. And once these clouds approaches the coastal areas, especially the northern parts, it becomes heaped and cumuliform, which is amenable and suitable for cloud seeding operations. During summertime, the mountainous terrains to the eastern region, actually it's a mercy from God to the UAE that developing and helping the cumuliform clouds to develop, especially during the afternoon times. Here we can see how the clouds are developing at that day during the afternoon time, and which is amenable for cloud seeding operations. Also here another description or can illustrate how the clouds are developing and sending the aircraft to the base of the cloud to release the hygroscopic materials to enhance the growth of the droplet and coalition and coalescence process. The other side stuck. Here we can see also the different parts of the wind, that how these parts of wind are positive to each other, and showing how the development of the clouds are giving up. So after that, after this study has been held in the UAE, we came out with a group of as a teamwork that the most suitable and proper material to be added to the cloud are the hygroscopic materials. These hygroscopic materials contains potassium chloride and sodium chloride as hygroscopic nuclei of condensation, causing the droplet to grow and one example of a cloud seeding operation that's been held in August, for example, the aircraft can be seen on the yellow track moving toward the target of the cloud, and then it seeds the clouds. And during the burning of hygroscopic, which takes about 3 to 4 minutes, it goes to another heading for another target of the cloud. The most frequent convective clouds during summertime are along the eastern regions and to the western regions. You can say about 4 days out of 1 week, every day, about 4 days from 1 week, that we are experiencing good convective clouds and amenable for cloud seeding operations. So we have tremendous activities since we started the cloud seeding in the country, UAE. As been mentioned, from 1982 to 92, Operation Cloud Seeding. In 2001 and 2002, we did the feasibility studies concerns to the cloud validity, availability and assessment of the clouds. And 2005, we announced about the UAE prize for cloud seeding, and since that time, we approved that cloud seeding is beneficial to the clouds and can extract more water from the cloud. Different countries are operating or deploying the cloud seeding, some of them for rainfall enhancement, and some of them for hail suppression. And some other countries are using both for rain enhancement and hail suppression. This is actually to a study case for 2020. We held about 390 cloud seeding operations in a total number of flying 1,000. And the collected amount of rain was about 5.6 billion of cubic meter being received at the top of the surface. And if we're saying that these rainy clouds being treated by cloud seeding with 50%, with a ratio of 10% increasing of rain or extracting more water from the rain, which is equivalent to about 280 million cubic meters. If you now imagine that, or you put in your consideration that each cubic meter is cost through the desalination plant about $0.1. So the outcomes, it will cost the desalination about $86 million, while the cost or the budget that we are paying for the cloud seeding operation for the country is about $3.5 million. So the ratio is 1 to 25 comparing to the desalination. Thank you very much.
Thank you, Sufyan. Interested work and effort. Now we'll move to Ms. Alia for your presentation, the director of the program. Please go ahead.
Thank you very much, Dr. Mohammed. It's great today, and it's a very good opportunity to showcase the UAE effort in rain enhancement. I'll be showcase all the efforts in terms of research and how this can tackle the water scarcity issue for the whole world, not only for the UAE. So at the beginning, I'll start with the importance of rain enhancement and why we are focusing on this and why we are putting more investments in research in addition to operations. So when it comes to the UAE climate, it's dry and we have less than 100 millimeters per year with a very high evaporation rate and a low rate of groundwater recharge. In addition to that, nearly half of the world's population will be suffering from water stress by 2030. And this is as a result of accelerating climate change. We have also the pressure of population growth and economic expansion that adds additional pressure on the existing water supply. And the most important point here is when we consider cloud seeding, we consider it as a contributor to achieve water security as an economically valuable technique and a cost-effective technique as well. So since 2015, an initiative or an international research initiative from the UAE Ministry of Presidential Affairs have launched a program which is called the UAE Research Program for Enhancement Science. This program offers a grant of $1.5 million to each innovative proposal. Of course, this is dispersed in a 3-year period, and it's giving in a sort of grants, working closely with the National Center of Meteorology and the R&D team in the National Center of Meteorology, working closely with them, going through all of the challenges, making sure that the outcomes are really aligned with the strategies and aligned with what have been proposed as well. The invitation goes to all researchers from domestic, foreign, public, private, non-profit and profit organizations. In some cases we have individuals, but we do highly encourage to have research collaborations between them to reach the maximum result for the proposal or for the project, research project. What we aim to is to contribute to the water security through enhancing rainfall amounts, not only in the UAE but for all arid and semi-arid region in the world. This is by advancing the science, technology and implementations of rain enhancement, spurring additional investments in this and the research funding and partnerships, of course, globally. We have some pillars that we focus on to reach our objectives. And this is including advancing scientific understanding in the field, developing state-of-the-art practices and operations techniques, enhancing the level of research and innovation in this field, positioning the UAE as the hub, the global hub of rain enhancement in terms of science, technology, innovation, and encouraging scientists and researchers on international research collaborations in this field. Of course, to find alternative solutions and sustainable solutions to tackle water scarcity here. The most important pillar here is also to grab attention for the new generation to come into this field and to contribute. through our capacity building activities done through our awardees and the projects. When we come to the targeted research areas we are looking for, since we start by cycle 1 until cycle 4, we have 3 main categories here we are looking for, or areas we can say about. The first one is the fundamental understanding of science. This includes the cloud microphysics, dynamics and thermodynamics, characterization of optimal cloud seeding materials and the delivery means of that, nowcasting and forecasting. In addition to that, the physical chain of events that leads to cloud formation and rainfall, aerosol and cloud interactions, the impact of cloud seeding methods on the cloud physics and dynamics. The second category or area we are also targeting is modeling and data analysis. We're looking into the analysis of historical and new data and creation of databases, and we're looking into the multi-scale modeling of relevant atmospheric processes. We are also looking into the areas that relates to observations, technologies and instrumentation, looking into the production of characterization of alternative approaches and materials, looking into the seeding methodologies to remote sensing and in-situ observation techniques and technologies. In addition to that, looking also into the new technologies and approaches other than cloud seeding to enhance rain enhancement, to enhance the rainfall, and looking into the field experiments and campaigns in this, and focusing more into more field campaigns in this. Another area also, which is a very important area, is the advances in weather modeling and forecasting, using artificial intelligence techniques and using of Ansible modeling like multi-model or multi-physics that determine optimal cloud seeding timing and location. And one of the areas that have been also added to the cycle 4 solicitation is the evaluation of rain enhancement efficacy, which includes evaluation of warm and cold phase cloud physical processes, utilizing the use of cloud chambers, for example, and the use of randomized inputs and statistical methods of evaluation of cloud seeding. Another important area we also focus on and we highly encourage is the innovation in rain enhancement systems, looking into the integration of new measurement and numerical tools, looking into testing and leveraging models of rain enhancement strategies, and the creation of test beds for a mix of field campaigns with that focus into in-situ upper measurements or ground measurements here. Since we started the program, one of the important approach we went through is to prepare for a proper and a strong outreach plan to build this a strong awareness of rain enhancement into the scientific community, directly and indirectly, into different fields and into different pool of experts. We wanted to reach out to make sure that what we find out is not only a quantity of proposals, but the quality, the high quality of proposals that really can give us and that contribute to this field effectively. So after this part, with the program outreach, we had since 2015 till 2021, we had 70 countries involved, around 3,014 stakeholders, with 504 researchers engaged in the program. The growth of submissions showed a high interest in participating in this field. It is a niche field, but the high interest through the cycles lead to more applications and more submissions in that during the four cycles. One of the most important questions maybe, and that we have been asked since we start till today, is that, okay, how do you choose the awardees and how do you select them? How can we make sure that what you select is really the premium and the good project that really can come out with outcomes that we really can say later on that translates into operations and have an effective or an enhancement in the methodologies of the cloud seeding. So here we put a lot of focus on the review stage. We have 2 review stages after the submission phases. The first one is the pre-proposal review stage, as you see, and the full proposal review stage with 5 main criteria. The most important criteria, which has 30% of the score, is the scientific and technical merit of the project. Then we have the investigators and the team, how solid they are. This is 25% of the score, and then the scientific approach of the project, which is 20%, and their plan for the capacity building part or component. This has also 15% on the project, and 10% goes to the resources need for this particular project.
Is it international committee to choose the?
Sure, this goes through a merit review process by an international pool of reviewers. But of course, the identity of the reviewers remain confidential for the whole process, just to make sure that there is no any conflicts that can happen. We make sure through the process that, and we look into this very careful, that there is no any conflict of interest between the scientists or the researchers that applies and between the reviewers, since the field is very niche and the community here is really small if we come to the rain enhancement scientific community. If we come to the research areas that have been covered through the 3 cycles when we awarded 9 projects so far. So we have covered so far different areas: remote sensing and data analysis, aerosol cloud interactions, cloud dynamics and physics, artificial intelligence, nanotechnology and the use of nanotechnology and material science in developing new material, simulations and modelings, electrical properties of the particles and studying this electrical properties, and land cover modification. So these are the areas that have been covered by our awardees so far, looking into for the future to cover more gaps in this field to make sure that we have the maximum covered in terms of research and research outcomes. I'll go through the awardees one by one. The first awardee from the first cycle is a Japanese awardee from Nagoya University, Professor Masataka Murakami. The second one is Professor Linda Zhu from Khalifa University in the UAE. Professor Volker Wolfmeyer from University of Hohenheim from Germany. We have Professor Hanneli Korhonen also from the Finnish Meteorological Institute. Professor Giles Harrison from Reading University in UK, and Dr. Paul Lawson from SPEC Incorporated from United States. Dr. Ali Abshev from Russia, from the Hail Suppression Research Center. Professor Eric Fru from University of Colorado in US, and Dr. Lilian Zhu from China. Maybe this infographic will demonstrate all of the 9 projects have been awarded and how this can really contribute to the field, to the rain enhancement field, covering different areas, but how this all come together and work and collaborate together, sometimes in some campaigns, in some research components related to their projects. So when it comes to Professor Masataka Murakami, for example, his project is about advanced study on precipitation enhancement in arid and semi-arid regions. For Professor Linda Zhu, using nanotechnology, she developed cloud seeding material, a new novel material that enhance the rain droplet formation. We have Professor Volker Wolfmeyer, which studied, the project is about optimizing cloud seeding by advanced remote sensing and land cover modification. From the second cycle, we can see Professor Giles Harrison studying the electrical aspects of rain enhancement, or rain generation, sorry. Dr. Paul Lawson studying the microphysics of convective clouds and the effects of the hygroscopic seeding on rain enhancement. We have the Finnish team under Professor Hanneli Korhonen. The study is about optimization of aerosol seeding and rain enhancement strategies. Coming into the third cycle, we have three other projects. Dr. Ali Abshev on the creation of updrafts for the formation of artificial clouds and rainfall. And this project, we are working on it right now this year in a campaign of 2 phases. First phase have been done, we have finished the first phase by the first quarter of the year. Hopefully, like after 1 month from now, we will be starting the second phase of the campaign, and this will be proving a really new concept in rain enhancement, which is the creation of artificial updrafts here. Professor Eric Froh from Colorado University his project is about targeted observation and seeding using autonomous unmanned aircraft systems. And again, the campaign of this project was this year, and we just announced it 2 days ago. And there are some positive results coming out, but will be announced later on very soon with some publications coming out. And in addition to that, also we will be announcing that in coming workshops and in the coming forum, International Rain Enhancement Forum. The last project here, which is for Dr. Lilenju, and he's using advanced numerical modeling, and he will come up with a new, the main outcome here is with the design of a cloud chamber. Out of the 9 projects, there was a very important need to translate the outcomes and the and all the results of the awardees into tangible results that can really be easily transferred into the operations and enhance the efficiency of the operations, so that we can use it not only here in the UAE, even other countries can use this in their operations. One of these applied research projects is integrating all of the awardee projects modeling works. So all of the schemes have been integrated into one unified multi-component atmospheric model. This is with collaboration with a university, with the Khalifa University, between the National Center of Meteorology and Khalifa University, and this will be a tangible result that will have a very positive impact in our in forecasting for the rain enhancement. And the second applied research project is testing the nanomaterials that have been developed by Professor Linda Zhu. And we went through a series of steps in this, starting with laboratory and cloud chamber tests, going into, of course, airborne tests on this. 2 airborne tests so far have been done, one in the UAE 2 years ago, and the last one was 1 month ago in Texas, showing promising results in the efficiency of the material. So it showed that, first of all, it shows that the efficiency of the material is 3 times better than the current material used in the seeding operation. And more results will come out in some papers very soon, in some publications that will be papers that will be published very soon about that. And of course, we can say that this material have obtained a patent so far, and we can say that the promising results we have from this material can lead to having a new material from the UAE to the world that can be used and that can be one day maybe replacing this material with the old one that has less efficiency actually. When it comes now to the outcomes of the program, maybe you will think that, okay, with all of these investments done in the program, the $1.5 million given to each project, and this support given, this high support given in terms of grants, facilities, logistics support and data and all of this push and support in this field. So why is all of this done? What we will reach at the end from all of this, or what we will reach in the future. So maybe this consolidates and give the development plans of what we will reach out of the outcomes. We have it into 3 categories. We have the observations, we have the modeling, and we have the technology. So if we come to the observations, we have airborne and ground-based information or data, and this is of course very important outcome, because when you have a rich data that can be used later on with the coming scientists, with coming projects, not necessarily for the projects we're working through now, but we need it for the research in future. So this is very important to keep it there, and very important, the most important thing is to share it also with other scientists, with other research institutions all over the world, to get the maximum results of their projects. And in terms of modeling, as I said, the integration of all the schemes of the awardees' work will be put in a unified model. This model will be included in the CRAE. It's a new computing system in the National Center of Meteorology that have been announced very soon, and this will be very, very positive and very important later on for any research work done by the center and by any university or by any research entity or academic entity that might need someday a strong computing system like that. In terms of technology, and this is the most important maybe outcome we are looking for in this program. When we come to the technology, when I say that we need to reach in a point where we have tangible results, take it there, translating it into operations and using it in our operations, we have to make sure that we have new technologies, so that we have an advanced methodology, we have an advanced, more efficient seeding operation here. The technologies we have now so far, we have 4 include outcomes and technologies, new technologies, the seeding material. And as I said, we are taking this to be deployed very soon. We have the unmanned aerial vehicles, and this is through 2 projects. The project that studies the target, or that focuses on the targeted observation and seeding, and another project that studied the electrical aspects of rain generation. So the use of the UAVs were very important to prove the concept of using it in seeding and using it in measurements as well. Also, we have the cloud formation, or we can say the artificial updrafts formation, and this is the Russian project. And this if we can prove that this happens, this will help a lot, and will reach to it will break the results and break the outcomes of this field, maybe, not only the program. And also the cloud chamber and the design, the new cloud chamber design that will come out after some studies and assessments. It can be also deployed in the future. One also of the most important questions we have, that what is the supports you give to the scientists and researchers? How do you help them? How do you make this work together in a joint team together? So it's not only in a sort of grants. In addition to the grant that we give to the each innovative proposal to start their project and to work in it through their research components, we also support in terms of continuous technical support, assistance in some provision of needed data, historical data, logistics, facilities, a lot of even working together with some experts from the National Center of Meteorology, giving some advices and being involved in facing some challenges they go through. This is one thing. And the other part is also monitoring each project in terms of the budget, in terms of the timeline, in terms of any needed support of experts, collaborations. We do come here and We come up sometimes with some considerations. We have some recommendations out of this that sometimes we have to collaborate with others and work together in it. So from the program so far, we have some important highlights, we can say, and achievements. Around 74 published scientific articles came out in 24 articles. We have 4 obtained patents coming out, and there is one on the way, a new one, and around 97 conference proceedings from the awardees and from the program secretariat and the center as well. The UAE became a key platform of rain enhancement research as part of its global efforts in weather modification. As part of our aim to reach in a point where we can say that the UAE is leading this science, the technology, the innovation in this science through research in rain enhancement. And as I said, because we are aiming to be a global hub, it's very important to have a platform maybe that can really can work out here and gathers all the scientists and researchers from all over the world, having them all in one international forum regularly. We have it now every 2 years. Every 2 years we'll have a new edition of this IRF, or the International Rain Enhancement Forum. We reached by the last edition around 100,000 attendees, and it was virtual. We are covering lots of pillars in this forum, such as the innovation, the applied research, collaboration, artificial intelligence, and the capacity building in this field. And this is very important to take the field further in the future. Right now we are, of course, the awardees there for the first 3 cycles, but right now we are in the 4th cycle that we have announced last January. We went through submission phases and review phases, and now we are in a stage where we selected already the awardees that will be announced in the coming January, hopefully. Here are some numbers. Generally from the 4th cycle, we received 81 pre-proposals from 378 researchers from 159 institutions from 37 countries. And this is how you can see it in the map and the geographical reach of the program. Here are some important educational research institutions that submitted, and governmental research institutions. Thank you very much. And
thank you, Ms. Alia. The thing I like that the program is stimulate the scientists around the globe, as well as the application of the science, the outcomes. Thank you both, Mr. Sufyan and Ms. Alia.
No,
I will start the discussion with Ms. Alia. My first question to you, you mentioned in the presentation that you are going to announce the 4th cycle awardees on January 2022. So when will be the call of submission of the 5th cycle?
Sure. We will be announcing the 4th cycle awardees on January. 1 year after that, we will be opening for submission for the 5th cycle. The reason is that there is a gap of a year, is that we will be updating more into this according to the outcomes of the projects before opening on January 2023.
Mr. Sufyan, thank you, Mr. Alia. Mr. Sufyan, regarding the seeding material currently used by the UAE, does it have any impact on the environment?
Unfortunately, nothing, fortunately, because these materials are natural source, potassium chloride and sodium chloride, which are adequate in the atmosphere. And even some other countries that using silver iodide, which is toxic materials, these people, they were been doing the operation for more than 50 years. And they tested the underground water and the aquifers. They didn't find any toxic material such as silver iodide, because they are using just a small amount.
So The cloud, as you know, the cloud seeding tends to be debatable. What is the UAE perspective on this matter?
Yeah, actually in 2003 and 2004, we collected about 150 cloud seeding operations that we intend to make this deployment on the amenable clouds for cloud seeding. And we only, we find out after using the randomized statistical experiment that 10 to 15% an extra amount you can expel out from the cloud and in turbid atmosphere, because the pollutants are working as nuclei of condensation. And this ratio actually elevated to about 25% in clean atmosphere. But most of the time that the atmosphere of the UAE is polluted and turbid.
So there is a cost in cloud seeding.
Yeah.
So compared to the desalination,
Yeah.
how cost effective is the cloud seeding?
Yeah, it's globally it is between 1 to 60 actually. But the last case that been studied in the National Center of Meteorology, it was showing 1 to 25. That we are, for example, in 2020, we bid for the cloud seeding about 3.5 million. Compared to the desalination, the cost is about 86 million. So the return is more than 50.
Yeah, interesting.
But the good thing that desalination, you can use the water available from the sea at any time. But for us, we are searching or looking for the amenable and suitable clouds to obey the cloud seeding operations.
Ali, are you looking for new research areas in fifth cycle?
Sure, there will be, according, of course, taking into consideration all of the research work done so far, and with the coming outcomes as well, there is always need to update the program solicitation in terms of areas, looking into the promising areas in this. So next year there will be an international pool of scientists that will be gathering again in the UAE, discussing more the areas and looking into the promising areas and gaps that needs to be filled, and this will be updated in the new solicitation for cycle 5.
Very good, very good. So tell us brief, please, what are you trying to achieve here throughout this initiative?
Of course, this initiative comes out due to the high importance of the rain enhancement, and how can we really come out with this as a contributor to the water security issue, how this can really be part of a multi-effort done in the UAE in tackling water security scarcity issues and the climate change effects. So the rain enhancement is considered one of important contributor in this. When we focus more into the research and innovation in this field, I think we can reach in a place that we can really go beyond the boundaries in this field in terms of science and technology. And at the end, the UAE here will be playing a leading role in taking this field or this science further in the future.
Thank you, thank you, Ms. Ali.
It is not for the own good of the UAE alone,
Sure.
it's for all the world.
Yes. Thank you, Mr. Sufyan. Thank you, Mr. Ali,
Thank
for
you
this
so much.
insight on the rainfall matter.
Thank you, Dr.
I would like to thank all the attendees here or virtually and for joining us today. Thank you very much.
Thank you.